Hi children, welcome to today's class. For last few classes, we have learned about the different modes of transmission of heat, conduction, convection and radiation. Today we are going to study the next topic in our chapter, thermal expansion. What are the changes that happen when a solid is heated? Let's do an experiment. Cut off the middle portion of a cardboard sheet. Fix two aluminium plates using cycle screws on the cardboard sheet as shown here. Connect these plates to a battery and a bulb using wires. Heat the aluminium plate using a lighted candle. What do you observe? Yes, the bulb glows. While heating, the aluminium sheets get heated and it expands. So the circuit becomes closed and bulb glows. If we extinguish the flame and allow the sheets to cool, the aluminium plate contracts. Due to this contraction, the circuit is opened and the bulb stops glowing. What do you understand from this? Yes. Solids expand on heating and on losing heat they contract. Let's do another experiment that proves this point. Collect the equipment as shown in the figure. Pass the metal ball through the ring and it passes exactly through the ring. Now, heat the metal ball over the flame for few minutes. You will be surprised to see that after heating, the ball does not pass through the ring. The size of ball increases. Now, allow the ball to cool down to room temperature. If we again pass the ball, it easily passes through the ring. This shows the metallic ball on heating, its size increases. So it doesn't pass through the ring. And if it cools, it can easily pass through the ring. So we can conclude that solids expand on heating, on losing heat they contract. Can you find out any situation in our daily life which made use of this? Yes. Little gaps are left behind the sections of the railway track. It is because the rails expand on sunny days. Otherwise, the rails will be deformed, causing danger. Concrete bridges were built leaving gaps between the joints of concrete slabs. The gaps in joints are needed to keep the bridge from buckling when the concrete expands on hot summer days. Do liquids too expand on heating? Let's see. Take a big injection bottle filled with colored water. Make a small hole in its rubber lid. Remove the metallic portion of an empty pen. Refill and fix it into the hole. Keep this bottle partially immersed in the vessel containing hot water. What do you observe? Colored water expands on heating and it comes out from the injection tube. Remove the bottle from the hot water and let it cool for some time. Then the liquid level falls. This shows liquid also expand on heating and it contract on cooling. The laboratory thermometer and clinical thermometer works on the basis of the ability of liquids to expand and contract. The bulb at the end of the thermometer contains mercury. There is a narrow vacuum tube adjacent to the bulb. Measurements are marked on the tube. Clinical thermometer is designed only to measure body temperature. Laboratory thermometer is used to measure temperatures below 200 degrees Celsius. In clinical thermometer, the marking is usually from 35 degrees Celsius to 42 degrees Celsius. While in laboratory thermometer, the markings are from minus 10 degrees Celsius to 110 degrees Celsius. Look at this video and carefully observe how to use a clinical and laboratory thermometer. Clinical thermometer are developed for measuring human body temperature. The normal human body temperature is 37 degrees Celsius, which can fluctuate between the ranges from 35 degrees Celsius to 42 degrees Celsius. The level of mercury tells our body temperature in degrees Celsius. Laboratory thermometer is used for measuring temperatures other than human body temperature. That is, it is designed for lab purposes such as checking boiling point, freezing point, or temperature of other substances. Let's see the thermal expansion in gases. Fix a plastic tube in the lid of an injection bottle. Immerse the free end of the tube in water taken in a vessel. Keep the bottle partially immersed in hot water. What do you observe? Yes, bubbles comes out from the other end of the tube. When the bottle immersed in hot water, the air inside it expands and comes out through water as bubbles. When this bottle immersed in ice water, the air inside the bottle contracts on cooling, and the water from the vessel moves inside the bottle through the tube. This shows gases expand on heating and contract on cooling. Air holes are made near the ceilings in room. Do you know the reason for this? Yes, air in room expands on heating. Hot air moves up and goes through the air holes. Also, cold air comes from outside into the room. It reduces heat in the room. So, air holes are made near the ceilings in the room. Next one. Long bridges are constructed as different spans. The reason is, if there is only one span, bridge expands on heating and bend. So, it is constructed in different spans. Hot water is poured in order to separate two glass plates that are stuck together. If it is poured in hot water, the outer glass expands when it gets heat. So, we can easily take it out. In all the above cases, we have seen the application of thermal expansion. We can find out many such examples in our daily life. Try it and see you in the next class. Thank you.